Welcome to today's presentation on designing an online banking system. This case study will walk you through the core aspects of building an online banking system, including its components, challenges, and high-level design. By the end of this session, you will have a better understanding of the key concepts involved in designing a secure, scalable, and efficient online banking system. Let's begin with an overview of the online banking system. In today's digital world, online banking is critical for managing day-to-day financial operations. Key features typically include account management, real-time transactions, fund transfers, bill payments, loan management, and user notifications. At the heart of these systems lies the importance of providing a seamless user experience while maintaining a high level of security. Now let's look at some of the key challenges when designing an online banking system. One of the primary concerns is security. Online banking systems are prime targets for cyber criminals, and thus fraud prevention, data protection, and identity theft must be top priorities. Another challenge is ensuring high availability. Financial services must be available 24 by 7, and system downtime can have significant consequences. Lastly, regulatory compliance must be strictly adhered to, such as PCI DSS and GDPR, to ensure the system meets the necessary legal and financial standards. To design an efficient online banking system, it's essential to understand its core components. First, authentication and authorization are critical to ensure that users can securely log in and access their accounts. Multi-factor authentication and OAuth 2.0 are widely used in this context. Then we have transaction management, which handles real-time transfers, payments, and ensuring data consistency with ACID compliance. Finally, user management ensures that users can manage their profiles, reset passwords, and update personal information, while fraud detection and audit logging help in ensuring the system's integrity. Let's continue with more core components of an online banking system. Security framework plays a crucial role in ensuring all communications and sensitive data remain protected. This can include encryption technologies such as TLS or SSL for data in transit and AES for data at rest. In addition, fraud detection systems help identify unusual activity by monitoring patterns and analyzing potential threats. Lastly, audit logging is essential for tracking user activity and ensuring regulatory compliance. Now let's focus on database design. For online banking systems, relational databases such as PostgreSQL and MySQL are typically used to store structured data like account information, transaction records, and customer details. However, NoSQL databases like MongoDB can also be useful for storing unstructured data or for analytics. Additionally, banking systems must manage vast amounts of transaction data securely, and databases must be assigned to handle these requirements efficiently. Integrating with external systems is also crucial in the design of an online banking system. For instance, payment gateways allow the bank to process payments from external parties, and fraud detection tools can help identify fraudulent activities. Additionally, integrating APIs for real-time communication with other financial institutions is vital for services such as fund transfers, checking account balances, or processing loan applications. Let's now dive into the high-level design or HLD of an online banking system. The, the HLD provides a bird's eye view of the system's architecture, focusing on key components like authentication and authorization, user management, transaction processing, and external integrations. We must also address considerations like scalability, fault tolerance, security, and availability when designing this architecture. Authentication and security design are essential to protect the system from unauthorized access and threats. A robust login system with multi-factor authentication is a must. Session management ensures users maintain authenticated throughout their session using technologies like JWT or OAuth. Moreover, encryption protocols like TLS, SSL ensure data is encrypted during transmission, and AES ensures data is protected at rest. When designing transaction processing, the system must be capable of handling multiple types of transactions in real time. This includes transaction initiation, processing, and confirmation. Message queues like Kafka or RabbitMQ are essential for ensuring reliable processing. It's also important to consider whether transactions should be processed in real time or through batch processing, as this impacts the speed and efficiency of the system. To achieve high availability and scalability, the online banking system must be able to handle increased traffic and scale with growing user demands. Load balancers distribute traffic across multiple servers, ensuring no single server is overloaded. Database sharding involves dividing the database into smaller, more manageable parts, improving performance and scalability. Additionally, failover strategies like active-active and active-passive configurations ensure the system remains operational even if one component fails. A strong monitoring system is essential for ensuring that the banking system runs smoothly. System monitoring tools like Prometheus and Grafana provide real-time insights into the health of the system. Additionally, altering systems detect anomalies or failures and notify the development and operations teams. This helps quickly resolve issues before they impact users. Let's now move to our hands-on activity. In part 1, we will brainstorm and start designing the architecture for an online banking system. Begin by identifying the key use cases such as user registration, login, transaction processing, bill payments, and fraud detection. Once identified, we can move on to creating a draft of the system's high-level architecture. In part 2, we will refine the HLD. After receiving feedback, we can enhance the design, making adjustments to ensure that it addresses all the necessary requirements. This includes updating the components, refining the data flow, and ensuring the system is scalable, secure, and efficient. Finally, let's review and provide feedback on the drafts. We will focus on key aspects such as scalability, ensuring the system can handle a large number of users. Security is another crucial point. We need to assess the robustness of authentication and data protection. Fault tolerance will help us ensure that system can recover from failures, and compliance with financial regulations must be verified. By the end of this session, you should be able to design a high-level architecture for an online banking system. You will have learned how to address critical aspects like security, transaction management, scalability, availability, and compliance. Thank you for joining this presentation today, and I hope you now have a better understanding of how to approach designing a complex system like an online banking platform.